So good afternoon, everyone. I would like to kindly welcome you today at this online event. We will present collaborative doctoral program, which we offer with JRC Ispra and our faculty, of course. My name is Vesna Gračar. I'm the head of the international office, and I'm also coordinator of this program. So my email is actually the contact email you're writing to. Today we will host presenters from JRC and also mentors of the program on the specific topics, and of course two of students who are, one was already working at the JRC and one is working on the topic we will present. The event will take maximum 40 minutes, and I would like to just remind you that the event is recording. So if you do not want to be recorded, please turn your camera on. And what I would like to explain also is that all the questions will be answered in the last part, so after the presentations. And I would also like to ask participants to turn off your microphones, because it will be easier to not make any extra noise for the presenters. So thank you for that. Okay, so first of all, now I would like to ask Ms. Zoja Bajl from Joint Research Center from Ispra, from Italy, because this program is held with them, and she will present some basic information about the JRC, how is it working, what they are doing, and so on. So please, Zoja. Start with the presentation.
Okay. Hello, everyone. I'm Zoja Bajl, and I'm here with Ierica Zupan, who is the program leader of CDP program. This stands for Collaborative Doctoral Partnership, which is an initiative of the Joint Research Center, or the JRC. And today we're here to tell you a little bit about the JRC and CDP. Ierica is currently in Brussels, and I'm calling from Ispra, Italy. The JRC is a science and knowledge service of European Commission, and it employs scientists to carry out research in order to provide independent scientific advice and support the EU policy. It has been an internal service of the European Commission for quite some time now, and it was working for the member state only in a limited scope. In the past years, this is changing, and JRC is opening more and more also to work with the member state. And one of the aspects of this is also our CDP program, because this is the first time that actually the European Commission is entering into the education system of the member states on the PhD level. One of the things that is important to know about the JRC is that it provides an independent research. It's bound by its own budget and the needs of the Commission. The JRC's research supports the policies of the Commission in every stage of the policy making. The JRC collaborates with the industry also in some of the areas which are also very limited, because it is extremely important to us that there is absolutely no conflict of interest. The JRC is being independent also toward the European Commission, and all the results that it provides are strictly science-based. The JRC employs 3,000 staff, and about 2,500 of them are based in Ispra, Italy. This is the biggest site. 70% of the staff are scientists and researchers who hold a PhD. The JRC has research facilities in 6 locations that are based in 5 member states. Its headquarters are based in Brussels, in Belgium. They're also doing prospective studies, looking into the future and trying to figure out where the development is going. Another location is in Gale, which is a nuclear facility, mainly testing and producing reference materials for the member states. The third one is in Karlsruhe in Germany, which is JRC's most active nuclear site. In Patton in the Netherlands, they're researching transport and energy and climate. They also research fuel. As already mentioned, the biggest site is in Ispra, Italy, and there they also have the widest area of research with many laboratories and unique research infrastructures. The staff of the Ispra site work on sustainable resources and transport, space, security, migration, health and consumer protection, energy efficiency and climate change, and growth and innovation. The last location is in Sevilla, Spain, where they're focusing on foresight studies and specialized on modeling. They work with artificial intelligence, big data measurements. And Ispra and Sevilla are the only locations that are not nuclear sites, and also the two locations for you that is most likely that you'll go to if you'll be enrolled in the CDP program, and that depends on the specific topic of your research. Now, a little bit about the CDP, the program. As already mentioned, this is a novel scheme for strategic collaboration between the JRC and higher education institutions on a doctoral level. You will find more about details in the program, about the program in the later stage of this presentation. I also believe that you heard a little bit in the previous presentations. But we like to say that this is a win-win collaboration. And that's because universities that take part gain a better understanding of research needs throughout the policy cycle. JRC obtains innovative research input and exchange of information with leading academic institutions. They get fresh views, fresh blood, so to say, from you. And PhD students get unique experience in higher education. They learn about research and policy making and get a good insight into the work of the JRC, and then can discover also other possibilities for scientific work that might not be strictly bound by the academia. So from my side, I think this is all. Vesna, you can take over.
Okay, so thank you, Zoya, for this presentation. I hope you're doing well in Ispra, in Italy.
Yes,
and being safe and,
thank you.
and healthy. Okay, so I will proceed with the presentation. Zoya briefly explained what CDP actually is. It's a 4 years program. It actually means that a student is employed as a researcher, and it's employed 2 years at Ispra in Italy and the rest of the time at the University of Ljubljana. So that means that 2 years the student spends in Italy and 2 years at our university. Of course, the students in the same time has to be enrolled at our doctoral program and has to also apply for it at the same time. So the date is 1st of June this year. And the position starts in 1st of October, the same time as the doctoral studies. So as I already mentioned, this is actually a research position with salaries in the time you're there from Ispra, and at the time you're at the University of Ljubljana from our part. We pay the tuition fee for the doctoral study program, and of course you get the best working environment in the world. Requirements. So who can actually apply? The citizens with EU nationality and with the country associated with the research framework programs. I just have to emphasize here that this outside EU nationalities, it can take quite long to get the safety of police clearance. Just to remind you that this this procedure can be quite long. And of course, the students who are applying, they have to fulfill all the enrollment requirements to apply for the doctoral study program. And the application, of course, has to be done both for the doctoral program and for the CDP program. So how do you apply? You have to apply online until June 1st. So this is the final deadline. Please do not forget. For the JRC program, you apply via Google Docs form, and you send the scanned documents to international office email. And at the same time, you have to apply for doctoral study program via IVŠ portal. And of course, for the doctoral study program, you have to also send a hard copy of the documents which are required to enroll and apply for this program. Documentation which needs to be sent is your CV, a motivation letter, 2 recommendation letters, usually from professors or your supervisors, original diploma degree, certified copy of the degree of diploma, and of course transcript of records. This should be scanned to email, and then later, of course, for the doctoral program as well as in a hard copy. So what are actually the selection criteria? Candidates will be selected according to, of course, the rank of GPA. This will be 20%. And the rest will be the committee's evaluation. This means 80%, like your CV, like your research experiences. Of course, the interview will be done later. And of course, you have to be willing to move to 2 years approximately to Ispra to work there. Okay, how the whole application process goes. As I already said, until 1st of June, you have to apply to both doctoral program and to the JRC program, right? And then in 14 days, approximately, we will invite you for the interview, which will be done online. And after the interview, in 7 days after the interview, we will inform you about the decision if you are accepted or not. Then if you are accepted from our side, then it has to be also done the interview at Ispra. It means you have to go there and meet them personally and do the interview. And then actually the final decision will be done after that. It should be in the mid of July, and in the same time, of course, you have to also enroll to the doctoral study program. This is done in September, and in October, you get the employment papers, and of course you will enroll the doctoral study program, and then you start to work. This is the whole procedure. We have 2 positions, and one is the position in IOT Security, and the other is position in Biometry. So today we host also mentors who are working and will be working with you. The first one is Professor Veljko Pejović, who will tell us something more about the IoT security topic, and the other is Professor Peter Per. They also will host their students who are working with them and tell us something about their experience on that topic and on working with mentors. So Veljko, can you please start with the presentation?
Yes, thank you very much for the introduction, Vesna. So my name is Veljko Pejović. I'm an assistant professor here at the Faculty of Computer and Information Science at the University of Ljubljana, where I lead research on mobile computing predominantly. And together with JRC Ispra, with their cybersecurity group, we are working on the security in the IoT domain, so in the Internet of Things. So why is that? Well, we have around 30 billion devices around us that are capable of connecting to internet, and most of these devices are actually capable of sensing the environment around us. And together, these devices, this whole ecosystem, represents a major source of vulnerability. There's buggy firmware in all these devices. They're difficult to update. The data that they sense might leak privacy, actually data that we don't want to have online. And they are also in a position where they have poor physical security, so they can easily be tampered with. So one of our goals is actually to make these environments safer. However, at the same time, we see these devices as an enabler of future security techniques. So we also see these devices as someone who knows a lot about you as a user and whose knowledge can be used to make authentication algorithms more robust. So the key ideas that we as researchers of computer science, together with experts in cybersecurity at JRC Ispra do, is to, first of all, use these sensors, use the data that we get from the IoT devices for more robust user authentication. So we, as Andras Krasovec, who's a student that we work with, will tell in the next few slides, we work on using machine learning techniques on the data sensed by these devices to figure out if it's the actual user who's allowed to, for example, enter a certain area where IoT devices are deployed, the user who entered the area, or perhaps it's someone else, an imposter. So to do that, we instruct these devices to sense the data, and then we use different techniques that put this data in some higher dimensional space so that we can disentangle users, so that the data can characterize behavior of different users, so that we can build classifiers that will later on tell whether the behavior that's detected in the environment corresponds to the behavior of the user that we expect to see in the environment. So the first part of our research is on actually strengthening these protocols for authentication using IoT devices. So distributed devices that each device individually is not that reliable, but when they work in a group, they tend to improve the security protocols. The second part that we are looking into with our collaboration with JRC Ispra is using the data that we can get from devices that we have in the IoT environment with the devices that we get in our pockets, such as smartphones that are more than 3 billion currently deployed in the world, and to see whether these devices can be somehow improved so that one of the critical issues in today's world, data leakage, is actually prevented. So one thing that JRC Ispra are working on is looking into how mobile applications sense data and then share data with perhaps other applications or third parties that you're not aware of. And we will then try to build protocols that will make the data transmission, make data sensing and data usage more secure. We are particularly also concerned with applications that are related to industry. So in industrial processes, there's more and more automatization, more and more sensing, and we are looking into how to make those environments more secure. So to get there, we need to start with some environment to work with. I'm happy to say that at the University of Ljubljana Faculty of Computer and Information Science, we already have a designated makerspace living lab where we can experiment with the protocols that we develop. So we can, in this dedicated space, deploy IoT devices and then run user studies, see how people behave, get sensor data. We also have all the necessary equipment at the faculty, including smartphones, wearables, Arduino boards, sensors. And for those who are interested in, say, wireless sensing, we have software-defined radio equipment, Wi-Fi pineapples, and so on. Finally, and I would say most importantly, at the faculty, we have long years of expertise in doing mobile computing, mobile sensing, wireless networking. This is all done as a part of the computer communication lab here at the Faculty of Computer and Information Science. So since we have all this infrastructure, including the human capital, what we need is actually you. We need someone who has high motivation to contribute to this space, someone who has solid knowledge of data manipulation, so data science and practical machine learning, and someone who's not afraid to get their hands dirty, meaning to build stuff using Arduino boards, using mobile programming, someone who's not afraid to do user studies, because after all, our research is not only theoretical, it does use theory, it does use machine learning concepts, but it actually leads towards European level policies, so it has to somehow translate to the practice. So we need to run actual user studies and try our concepts in the real world. And if this interests you, I suggest that you pay a special attention to the next few slides, where Andras Krašovec, who's a student who works with us, will describe his work and his experiences in JRC Ispra. Andras, can you please take control of the slides and introduce yourself?
Veljko, thank you very much. Hi, everyone. My name is Andras Krašovec. I'm a master's student here at the Faculty of Computer and Information Science. I'm just about to finish my studies, so at the moment I'm writing my thesis. Actually, I returned from the JRC about a month ago. I was there as a trainee, which is another option, which is, I guess, not interesting for you at the moment, but it's another option of collaboration between our faculty and the JRC. Firstly, I would like to talk about my experience there for a brief period, and then about my work. So the JRC Ispra, where I was, and as already Zoya mentioned, is the largest of the JRC sites. Yeah, it employs more than 2,000 researchers. It has crazy laboratories, 20 meters high, and it's an amazing place. I was really impressed by the sheer size and diversity of the stuff that they do there. Yes, our faculty collaborates with the cybersecurity unit, which is one of the smaller units at the JRC Ispra. It's really nice. It feels like a big family when you get there. I mean, from the moment I arrived there, everyone was really friendly to me and willing to help with my work. So I had a really pleasant experience working with them. For example, every Monday, you have a chance to present your work or to listen a presentation of one of your co-workers. So you get to see what's actually going on the policy level of the European Commission, which was a crazy thing for me to experience. I also spoke with many people there who are at the moment doing this collaborative program from other universities. They had a similar experience to mine, so they were all really pleased with their work and staying there. I also talked with some people who actually were there as the part of this program and are now employed there. So if you like the mountains, if you like Italy, if you like to live in nice environments, you can stay there for a much longer time than just your PhD. Okay, so my work was, my time researching there was mostly divided in two parts. Half of the time I was doing research, and half of the time I was writing a paper on it. So the paper was, let's say, an expected goal from the JRC in this collaboration, which was actually really nice, because at the same time when I was writing the paper, I was writing my thesis. So it was a nice cohesion of the two. Okay, so let's talk about what I am working on, in Veljko and all the others as well. Our goal is to devise a user identification and continuous authentication system by modeling user behavior. We want to achieve that by using different sensors, which makes sense because we're talking in the field of the IoT. So we employed sensors like the accelerometer, the gyroscope, some force sensors, some infrared sensors, We collected some CPU, memory, and network data from the PC, and all different sensors that are actually from which you cannot recognize a person directly. So no microphones, no video cameras, nothing like that. Okay, and the assignment that I had is comprised of two parts. First, which was for me a total novelty, and it was really nice to do and really interesting, was actually to devise the system itself. So we had to prepare all the Arduino devices, connect all the sensors, lay them out around the room, figure out how to deploy power to each device, then how to send all the sensor data to the server, then of course set up the server, set up the database, the delivery system of the data, and then test this environment. I was well quite shocked because it took me almost a month to test everything to get it to a working phase. After all that was done, we invited some volunteers to participate in our user studies. It took about 1 hour per user, so I prepared 3 different tasks that the user had to complete in this makerspace that Vilko mentioned. The tasks were, let's say, basic office tasks that you would do. Let's say write an email, type some text on the keyboard, fetch some documents from this place or that place. And yeah, we had 21 participants, and we collected about 16 hours worth of data. And then, of course, with the data collected came the second part, which was the data processing, which was a bit more my let's say, expertise from before. Yeah, firstly, before even applying any machine learning techniques or anything that was the main goal of the work, we had to validate the data, so to see if the data is okay, if we have some missing data, or if the sampling rate is okay. After that, we had to filter the data. There were some users who didn't oblige by the rules that were set in the experiment, so we had to throw those out and then extract the features from the data. So those were time and frequency specific features. Yeah, okay, that's it. After that, we started with some experimentations to see. Okay, let's start by this. Our goal was to firstly identify which user is currently present in the room, in the office, in the makerspace. And the second part, which was the most interesting one, was to devise a continuous authentication system. That means that the system checks every few seconds if the user who should be presented is the room is actually the user presented is the room. So if we have an imposter who tries to steal some data from the computer or something like that, the system should be able to detect this. Okay, so if I describe the system as it is at the moment, of course, it's still in development. The system itself, firstly, the data that is in real time, the data that is being picked up by the sensors is, of course, the features are extracted. Then when we perform a feature selection algorithm, so we only use a few features for each calculation. Then based on these features, we built a random forest classifier, which through testing, it showed that it was the best classifier for our approach, what we wanted to achieve. Then each tree in the forest votes for one of the legitimate users of the system. And it turned out that if we have an imposter, a different user who isn't the part of this legitimate system, the distribution of the votes per user is about equal. So the system cannot decide which user is currently present, which at the end means that we have an imposter. And the other way around, if we have a legitimate user still present in the place, vast majority of the trees votes for that user, so that it identifies that user. Yeah, that was just a brief description of my work, what I do most of the time in the JRC and here. I would just really like to say that I really enjoyed my time at the JRC working on these things. And if you're interested in topics about IoT and machine learning, I think this is a great opportunity to do world-class research on these topics. Yeah, that's it from my side.
Okay, so thank you very much, Andras and Professor Veljko Pejovic for explaining something about the machine learning topic. So we will proceed now with Professor Peter Per and student Peter Roth. Please proceed.
Hi, Vesna, thank you for the introduction. My name is Peter Per, professor at the faculty in the field of computer vision and biometrics. I hope that you're enjoying the webinar, getting all the right information, but I'll add a little more, of course. I will talk about another full-time position, but in the field of biometrics. Of course, since it relates to EU policies and consequently with JRC, it will reflect important topics that they are facing at the moment on the borders of the EU. I will actually focus on image-based biometric forensics. First thing first, I will extend main points from the call so that you will get better ideas of what might be behind them. So let's be as specific as it gets and name a few hot topics for the JRC at the moment, all representing unconstrained recognition challenges. Good. I took the control but didn't press the next button for the next slide. Good. So first one is latent fingerprints quality evaluation, with, of course, emphasis on detection and reconstruction of usable surface and disentanglement of feature space. By the way, what are the latents? Latents are indirectly obtained fingerprints, so not directly from the fingers as on the first two images here, but from the surface as on the third one. The next topic is about 3D fingerprints matchers with reconstruction of 3D targets from forensic trace evidence for presentation attacks and focus on developing methods for performance prediction of comparison algorithms. The last topic given here is online child abuse detection, where we will focus on utilizing local descriptors and convolutional neural networks. And of course, dimensionality reduction methods to select the robust set of features. A student, of course, will have certain influence on selection of the topic that he or she will be tackling. In the continuation, I will briefly sum up what we do in the computer vision lab, where the student will be working, but I would also here like to announce my colleague from the lab, Peter Roth, who is a very promising doctoral student working in the field of privacy preservation, and who will briefly, after me, explain his work touching two aspects given already on this slide. Mostly from the, of course, methodological point of view, but namely disentanglement of feature space and attacks. You might also be interested in what kind of prerequisites we have for the position, right? So you have to be fluent in one language. Yes, of course, I'm here speaking about a programming language, preferably that should be Python. Knowing something about buzzwords like artificial intelligence, machine learning, deep learning, computer vision is, of course, another plus. With other words, it's kind of expected that you listen to at least one course on artificial intelligence. Of course, your interest in the field is kind of a must. Okay, so let's jump to the introduction of the computer vision lab. So what can I say about the computer vision lab? We are altogether 40 members, around 2/3 working in the field of biometrics. Actually, we have a group within the lab named Biometrics Group with regular weekly meetings, a lot of flexibility within our work, and of course, as the slide says, rich computational resources. I can say that we are a very productive team in the last years. The next question, probably needing answers, should probably be what we focus on. So let's name a few subfields through images. Here is the first one. First, there is scleral segmentation and recognition through the vascular pattern that is presented in it. The next one is, well, we work on face recognition also in 3 dimensions and with landmark detection. Furthermore, we tackle ear recognition, and yes, in majority of cases, we tackle things with deep learning. The next one is iris recognition. Here we illustrate an end-to-end deep network that performs both segmentation and recognition within one single network. And if I jump to the last one that you already saw, I already mentioned that we are also concerned with privacy-preserving analytics, also known as de-identification or even anonymization. And Peter Roth, in this case, will now give you one glimpse into the work in this field. Peter, can you take over?
Hello. I hope you can hear me.
Yeah, we can.
Okay. Hello, everyone. My name is Peter Roth, and I'm currently a doctoral student in computer vision laboratory, and I'm conducting research on a topic, privacy preserving face analytics using deep learning methods. And I find this research topic important because face recognition technology is currently controversial, mainly because of the privacy-related aspects. Different countries have different views on face recognition technology. For example, China incorporated it into their mass surveillance systems, and on the other hand, San Francisco banned the usage of this technology in public spaces because it is privacy intrusive. In our laboratory, we recently developed a mechanism to remove sensitive information from biometric templates called PFR-net. That's the one you can see on this slide. Biometric templates are numerical representations of a face that are used for face verification. In other words, they are used for identity checks. You can see on this slide it's denoted with X. This is biometric template. Those templates are typically obtained using convolutional neural networks, and the problem of those templates is that they encode sensitive information which can be extracted by an informed attacker. On this scheme, you can see that using PFR-net, we were able to separate gender-related information from templates without compromising the utility of identity verification. So you can still know if that's the same person, but you cannot analyze his or her gender. So after gender-related information is separated, we can simply discard the gender part of the newly obtained PFR-net template, and we use only identity part to perform identity checks. On this ROC graph, the green surface represents the drop of gender classifiers performance, and you can see that the gender classifier performs much worse after gender information was removed from the template, and in the same manner, red surface represents the drop of verification performance, which is not affected much. We are also interested in how safe and reliable are state-of-the-art privacy-preserving methods for face analytics, and to evaluate how much sensitive information it is possible to conceal, we also need to play a role of an attacker who is trying to extract protected information. And this is kind of a cat and mouse game where you're trying to protect a certain type of sensitive information, and afterwards you try to get it back using the attack. So in this context, from the attacker's point of view, we are currently working on an anti-privacy net. Other researchers proposed multiple methods that aim to protect sensitive information on a raw image of a face. This means that they want to manipulate pixels on a raw image of a face such that identity checks are still possible, while the prediction of sensitive information is not possible anymore. On this example, the goal is to predict gender and identity of a person. On the original image, both classifiers perform well with 99% confidence. And after we protect gender-related information, only the performance of gender classifier drops, while the person on the image is incorrectly classified as female. And anti-privacy net aims to recover gender-related information. And in our experiments, we were able to recover a lot of gender-related information using this anti-privacy net. The goal of this work was to show that image-level techniques are maybe not as effective as they appear to be in terms of privacy preservation. And also anti-privacy net could be used as a benchmarking tool to assess the performance of newly developed privacy-preserving image-level techniques. And now I would also like to share some thoughts about the working environment of computer vision laboratory. I found all members of the lab very enthusiastic about technologies they developed, and they are willing to share their knowledge with students and co-workers. With the biometric group, we have weekly meetings where we discuss the progress, and those meetings are also a great opportunity to share ideas, to hear about the work of others, and to find new solutions. We have the opportunity to work with the latest technologies, which I personally find very interesting, and mentors are very good, and you can be sure to get high quality guidance. That's everything from my side. Please feel free also to contact me in person for more information, and thank you for your attention.
Thank you, Professor Per, and thank you, Peter Roth. So just a few important information in the end. More information about the call, about the doctoral program, can be found on our website. You can see the link here. Of course, do not forget to apply. The deadline is 1st of June this year. And if you have any additional questions, just contact me or mentors via email. My email is international.office. And you can also contact students if you have maybe any additional question. So I would like to thank all the participants and all the presenters to explain all information about the topics. I hope you received everything you like to know about the call, and that you can now apply, of course. So thank you for joining us, and I hope to see you next year at the Faculty of Computer and Information Science.